Hi students, welcome to Sunil's tutorial. I'm Sunil Mirwani and today we will be doing this chapter called as binomial theorem. Let's see this. Now what is binomial theorem? When you want to expand, when you want to do expansion of number which has degree greater than 3, then you use binomial theorem. 2x plus y upon 2 the whole raised to say 5. Right? Now there is a specific method for doing it. In fact, there is a formula, but instead of learning the formula, I'll show you how to do it. So when do you use binomial theorem? When you want to expand polynomials that have degree greater than 3. Because up to a degree of 3, you have formulas. When you want to expand to the power of 8, to the power of 9, then you use binomial theorem. Okay? How do we do this? You have 2x plus y upon 2 raised to 5. You write combination of 5, 0, leave some space, 5, 1, leave some space, 5, 2, leave some space, 5, 3, 5, 4 and 5, 5. I'm teaching you a method to write this. Instead of marking up the formula, this is what you have to do. Start with the highest, the polynomial 0 to 5. First term 2x raised to 5, the highest indice. 2x raised to 4, 2x raised to 3, 2x square and 2x raised to 1. Right? Then move on to the second term. Second term, you start only with the second term. Y upon 2 raised to 1, y upon 2 square, y upon 2 cube, y upon 2 raised to 4 and y upon 2 raised to 5. That's how you do expansion. Instead of learning the formula, that's a method to do the expansion for this. Right? Now let's expand this. C5 of 0 is 1. 2 raised to 5 is 32. This is 32x raised to 5. C5 of 1 is 5. Right? 2 raised to 4, 16 x raised to 4, y by 2. C5 of 2 is going to be 5 into 4 upon 2 into 1. We've learned this in permutation and combination, so we shouldn't have a problem here. Into 8x cube into y square by 4 plus C5 of 3, 5 into 4 into 3 upon 3 into 2 into 1 into 4x square into y cube by 8. C5 of 4, 5, 4, 3, 2 upon 4, 3, 2, 1 into 2x into y raised to 4 upon 16. C5 of 5, 1, y raised to 5 upon 32. Right? Do we get this in here? Now, this is going to be 32x raised to 5, 16, this I can cancel as 8, 8 5s are 40, x raised to 4y plus 4 2s are 8, 5 4s are 20, x cube y square plus, you have 3 and 3 getting cancelled, you have 2s are 4 2s are 8, 8 and 8 gets cancelled, so you will get what will remain is 5x square y cube plus 4 is gone, 3 is gone, 2 is gone, 2 1s are 2 8s are, so 5 upon 8 x y 4 plus y raised to 5 upon 32. That will be the expansion of this. Fine, do we get this in here? I'll show you one more sum so that you can follow this clearly. Let's assume I have x minus 1 upon x the whole raised to 6. Right? Let's see this. Raised to 6. Let's go by the method. First you write C6 of 0. Whatever is this number, that will be the end, r will be 0. Now go on increasing r consecutively. So this will be C6 of 1 plus C6 of 2 plus C6 of 3 plus C6 of 4 plus C6 of 5 plus C6 of 6, right? Then the first term, you write with this indice and go on reducing the indice by 1. So x raised to 6, x raised to 5, 4, 3, 2, 1. Second term. Now you have to be a little careful here. The second term is with minus sign. So this is going to be minus 1 upon x, minus 1 upon x square, minus 1 upon x cube, minus 1 upon x raised to 4, minus 1 upon x raised to 5, minus 1 upon x raised to 6. Right? Let's expand this. If I expand this, C6 of 1 is, C6 of 0 is 1 into x raised to 6 plus 6 into x raised to 5 into minus 1 upon x plus 6 into 5 upon 2 into 1 into x raised to 4. Minus square will give you positive 1 upon x square plus 6 into 5 into 4 upon 3 into 2 into 1 x cube into minus 1 upon x cube plus 6 into 5 into 4 into 3 upon 4 into 3 into 2 into 1 x square into 1 upon x raised to 4. Minus will become plus here, plus 6, C6 of 5 is going to be 6 because 6, 5, 4, 3, 2, 5, 4, 3, 2, 1 into x into minus 1 upon x raised to 5 into 1, sorry, plus 1 into 1 upon x raised to 6, right? So when I expand this, this is going to give me, x raised to 6 plus this, and this will get cancelled, so this will be minus 6x raised to 4, right, plus 5 3s are 15 x square minus 20 plus 15 upon x square minus 6 upon x raised to 4 plus 1 upon x raised to 6. That will be the expansion. Right? Simple basic maths. Now, let's try to make this thing a little more interesting. Suppose if I give you a sign like this, root 18 minus root 8 plus 1 the whole raised to 8 minus root 18 minus root 8 minus 1 the whole raised to 5, not 8, this is 5. Okay, let's try to see this sum. Now in binomial theorem you can expand two terms. Here we have three terms. So let's take one term at a time. Consider the bracket has three terms here. Consider root 18 minus root 8 plus 1 the whole raised to 5. Root 18 is 9 2s are 18. So root 18 can be written as 3 root 2, right? 8 is 4 2s are 8, can be written as 2 root 2 plus 1 the whole raised to 5. 3 root 2 minus 2 root 2 is root 2 plus 1 the whole raised to 5. 3 root 2 minus 2 root 2 is root 2 the whole raised to 5. This now can be written as C5 of 0, binomial expansion, plus C5 of 1 plus C5 of 2 plus C5 of 3 plus C5 of 4 plus C5 of 5. This is going to be root 2 raised to 5, root 2 raised to 4, root 2 raised to 3, root 2 square and root 2. The next term is 1. So this will be into 1, 1 square, 1 cube, 1 raised to 4, 1 raised to 5. Right? C5 of 0 is 1. 2 to the 4. So that will be 2 and 2. 4, 4 root 2. 2 raised to 5. 1, 2, root 2 square will give you 2. Another root 2 square will give you 2. So that's 2 to the 4. And the fifth root 2 will remain as it is. C5 of 1 is 5 into 4 plus 5 into 4 upon 2 into 1 into 2 root 2 plus 5, 4, 3, 3, 2, 1 into 2 plus 5 into root 2 plus 1 into 1. Right? So this is going to be 4 root 2 plus 20 plus 20 root 2 plus 20 plus 5 root 2 plus 2. So we found root 18 minus root 8 plus 1 is this. I'm going to just write this thing once again to explain this to you. We just found out that root 18 minus root 8 plus 1 the whole raised to 5 is nothing but 4 root 2 plus 20 plus 20 root 2 plus 20 plus 5 root 2 plus 2. One of you could definitely ask me a question, sir, why are you writing this whole thing? You could have simply added 4 root 2 plus 20 root 2 plus 5 root 2 and written that as 29 root 2 plus 42. I can do that, but I need to show you something, therefore I am not doing this. Right now let's write the expansion as it is, because there is another term there. Root 18 minus root 8 minus 1 the whole raised to 5. Now, when we were solving the first term, we had already found out that root 18 minus root 8 is nothing but root 2. Root 18 is 3 root 2, root 8 is 2 root 2. So that will give me just root 2. This was root 2 plus 1, this is root 2 minus 1. Both the terms are same except that the sign is opposite. When you have a subtraction sign, the expansion remains the same except that the alternative signs reverse. That means the expansion for root 2 minus 1, the whole raised to 5 will be 4 root 2, alternate signs reverse, minus 20 or plus 20 root 2 minus 20 plus 5 root 2 minus 2. So the expansion remains the same. Every alternate sign will take minus sign. If you have the same expansion between plus and minus, every alternate sign will take minus. Now, let's get to the sum. Therefore, I can say that root 18 minus root 8 plus 1 the whole raised to 5 minus root 18 minus root 8 minus 1 the whole raised to 5 is nothing but 4 root 2 plus 20 plus 20 root 2 plus 20 plus 5 root 2 plus 2 minus 4 root 2 minus 20 plus 20 root 2 minus 20 plus 5 root 2 minus 2. When
the last term should be 1. 1 into 1 is 1.
1. Yes. Yes. Please make that correction both the places. This is going to be 1. Right? Now, plus 4 root 2 minus 4 root 2 will get cancelled. 20 minus into minus plus 20. 20 plus 20, 40. These two terms will get cancelled, plus another 40 plus 2. So the answer for this is going to be 82. So the answer of root 18 minus 8 plus 1 raised to 5 minus root 18 minus 8, root 8 minus 1 raised to 5 is going to be 82. When you open the bracket and expand, this is what you will get. Right? Let's see another sum, guys. Find 99 raised to 4. Right? Now, 99 raised to 4 can be written as 100 minus 1 the whole raised to 4. 99 can be written as 100 minus 1 raised to 4. The indice is greater than 3. Therefore, you will expand by using binomial. So this is going to be C4 of 0 plus C4 of 1 plus C4 of 2 plus C4 of 3 plus C4 of 4. First you write the combination. 100 raised to 4, 100 raised to 3, 100 square and 100 the second time. Minus 1 square minus 1 cube minus 1 raised to 4. C4 of 0 is 1. 100 raised to 4. That means I'll have to, 100 has 2 zeros, raised to 4 means there will be 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 zeros here. Okay. Plus C4 of 1 is 4 into 100 raised to 3 is 6 zeros. 4 and 6. The number of zeros multiplied by whatever the indice is. There is a minus sign, so minus. Right? Plus 4 into 3 upon 2 into 1, 100 square, 4 zeros. Minus, because minus 1 cube will give you minus. C4 of 3 is 4.
Also will be plus now.
This is
Minus
plus,
1 square.
minus, plus, minus. Minus 1. This is minus 1 square, so I'll write it plus. Right? 4 into 100 plus C4 of 4 is 1, minus 1 raised to 4 is 1. So this is going to be 10 lakhs. No, it's more than 10 lakhs. Minus 4 and then 1, 2, 3, 4, 5, 6 zeros. This is 40 lakhs. 6. 1, 2, 3, 4 zeros. Minus 400 plus 2. Right? When you add, subtract all these terms,
So plus 1.
plus 1. I always end up making the same mistake. Right? Now, when you add, subtract all this, you will get 9605, 9601. 9605, 9601. That will be your answer. Right? I'd like to give you something like this. Try on your own. 2.02 the whole raised to 5. This should be a very interesting sum. Right? 2.02 the whole raised to 5 can be written as 2 plus 0.02 the whole raised to 5. Binomial expansion. This is C5 of 0 plus C5 of 1 plus C5 of 2 plus C5 of 3 plus C5 of 4 plus C5 of 5. Right? This can be written as 2 raised to 5, 2 raised to 4, 2 cube, 2 square into 2. Now we have a big problem, people. The expansion with decimal 0.02, 0.02 square, 0.02 cube, 0.02 the whole raised to 4, 0.02 the whole raised to 5. Should be very nice. C5 of 0 is 1, 2 raised to 5 is 32. Right? 5, 16 into 0.02. Right? Plus 5 into 4 upon 2 into 1 into 8. Decimal 2, when I square it, should be decimal 4. That means this will be 0.0008. I know a lot of students making mistake. Right? Plus 5, 4, 3, 3, 2, 1 into 4. 3, that means there should be 6 decimal places. and 1, 2, 3, 4, 5 and 8.
So that will be 4 now.
This is going to be 4. Right? Square, so 4. Next, this is going to be 5. This is going to be 5. C5, 4 is 5 into 2. This is going to be 8 decimal places. And 2 raised to 4 is 16. So 1, 2, 3, 4, 5, 6, 7, 8. 8 decimal places. Right? Plus C5, 5 is 1. This has to be 10 decimal places and 2 raised to 5 is 32. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? So when you multiply this, this is going to be equal to 32 plus 16 5s are 80 into 0.02 plus 8 to the 16, 16 5s are 80 into 0.0004 plus 3 and 3 gets cancelled. 2, 5 2s are 10, 10 4s are 40, 5 2s are 10, 10 4s are 40 into 2, 4, 5, 6, then 5 2s are 10 plus 0 into 0.1, 2, 3, 4, 5, 6, 7, 8 plus 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? Right? So when you multiply this, this is going to be 32. 80 into 0.02. 82s are 160. Right? 2 decimal places 160. 2 decimal places 1.60. 84s are 320. Right? 320. I need 0.0320, right? Plus 4 8s are 32. 32 and 1 decimal place will go. So 1, 2, 3, 4, 5, 6. So 5 decimal places. Because why will 1 decimal place go? Because I am multiplying by 10. 32 now. 1, 2, 3, 4, 5. Right? Plus multiplying by 10. So 1 decimal place becomes less. 1 0 will be less. So this will be 0.123451 plus 0.0000000032. When you add up all this, you will get the answer as 33.632 32 16 now the answer for this 2.02 raised to 5 is going to give you this. This will be the precise answer for this, right? Right, so you'll stop this here for the day. Thank you very much.